Hi guys, welcome back. This is Karthik here. Today we'll be discussing about strings. So basically in this video we'll just go through the strings, not including any data structures like stacks, or we won't be using dynamic programming as well. We'll just go through strings, and also they are easy problems from LeetCode. Basically, you can just type these titles in Google so that you will get those questions after watching this video. You can solve it also. Yeah, diving into this video. First question: remove outermost parenthesis. So you guys can see here. There's the input given and there's the output. So basically, what happens is here. Basically, this and set and this and set. So if we remove this parenthesis and this parenthesis, that is the outermost parenthesis, we get these two, the inner parenthesis as the output, and as well if we remove the outermost here and here, we'll get this parenthesis as here. So basically I'll mark it here, just a minute. This one, this one, and this one. So if we remove all these four brackets, we'll just get those three inner brackets. So yeah, there's the topic, or there's the idea. Um, so how do we solve this is we can use stack to implement this. By using stack, we can just like push all those brackets inside, and if whenever we encounter an closing bracket, we'll pop it off. Assuming that the stack is not being taught yet here, we'll just go through the basic string method. We'll use a counter here. So yeah, diving into the solution, this is the result array, uh, which stores the result, which stores the answer, and there's the counter. So yeah, how do we solve this problem is we'll have a counter, and we'll increase the counter by 1 whenever we encounter an opening bracket, and we will decrease the counter by 1 whenever we encounter a closing bracket. So how does this logic work is whenever balance, that is whenever we encounter an opening bracket. So if that balance is not 1, I mean if that balance is not 0, that is it is 1 or more than 1, basic definitely that is not an outermost bracket, because for this outermost bracket, the balance is 0. And for this one, the balance gets increased by 1. So the balance is 1. And for this one, it decreases by 1. So the balance is 0 again. So you guys can see here, this has balance as 0 and this has balance as 1. That is, the balance of the outermost bracket is 0 and the balance of the inner brackets are more than 0. That is the main logic we'll be working upon here. So yeah, first we have an for to iterate into the string. We go through the size of, that is the length of the string, and if the index is an opening bracket, and if the balance is more than 0, that is it is 1 or 2 or 3 or something, we'll add that bracket into the result array, that is the output array, that is the result array. So if the balance is greater than 0, that is if the balance is greater than 0 is the inner brackets, we'll add this inner bracket into the resulting array, and we'll increase the balance by 1, that is the counter value gets increased by 1. And else, that is if index is a closing bracket, first we'll decrease the balance by 1, because we are not decreasing the balance after this if statement, and we are decreasing the balance before the if statement, because if the balance is 0, then definitely it is going to be an outermost bracket. If the balance is not 0, that is if the balance has value, some value, definitely it is an inner bracket, and we must add that inner bracket into an output array. So yeah, that is what we are doing it here. If the balance is greater than 0, we'll add it into the array. But before that, we must decrease the value by 1. And after iterating through the whole loop, we'll just return the result. So yeah, there's the first question of our video. I hope you guys understood it. You guys can search up for this title, remove autonomous parenthesis, and you guys can solve it. So yeah, coming back to the second question, largest odd number. So in this, we have input as 52, and we must take the substring. That is, it must be an substring. It must be part of the string, and it must be an order. It must be an order. It's not, and it's not like, yeah, it's an order. It for example, here we have 52, so if we remove 2 we'll have 5, because 2 is an even number eventually, so we just have 5 as an odd number. Yeah, this case is fine. Here coming back, if we remove 6, still 420 is an even number. If we remove 0, still 42 is an even number. If we remove 2, still 4 is an even number. If we remove, so all these are even numbers, so the largest odd number is here an empty string. And now coming back here, if 3 5 4 2 7, right? So this is an even, this is an odd number, because 7 is an odd number, so the whole number is an odd number. So the largest odd number is 3 5 4 2 7. Now assuming that, if number is something like this, 3 5 4 3 6. So, so if the largest odd number in this is, we'll just try to remove the 6 here. So 3 5 4 3, and we'll check for this. Is this an odd number? Yes. Now you guys can ask a question like, what if we do like this, 6 3 5 4 3? Comparing this to the before number 3 5 4 3. So this one is wrong, because in question they told us to use a substring. We must use the same order here. So here you guys can see the order is 3 5 4 3. Yeah, you are correct. We can change 6 here, and eventually it will become very large when compared to 3 5 4 3. But we must use the substring here. So substring is like, just it is a part of the string, right? Yeah. Okay, now coming to the solution here. So what will be the logic here is, we'll just start at the ending place here. We'll check if it is an odd number or not. If it is an odd number, we'll just print, sorry for that, we'll just, oh my god, my bad, we'll just print that. We'll just print that. Yeah, coming back here. Now take this example, 3 5 4 2 7. We started from 7 here. 7 is an odd number, yeah. So we will print the whole string. No, if coming back here, 6 is an odd number, no. So we'll go back. That is, we'll decrease the value by 1. So now coming to 3. Is 3 an odd number? Yeah, definitely. So from here up to starting to this index, we'll just print it. That is all. That's the logic here. So for loop is for basically iterating to the whole string. Yeah, cool, sounds cool. Now, now we start at the index that is at the end of the string. That is at the end of the string, and we'll decrease the value by 1 every time. Okay. Now coming inside the loop, if num of I minus of 0, what does this mean is, so basically we have a string here, and we and we have a modulus symbol here. That is, basically we're trying to check if it is an even number or an odd number. We simply can't apply modulus on a string, so we must change the string into an integer. So to change a string into an integer, we must subtract 0 here. Cool. So 35427 minus string of 0 is normal integer 35427. Okay. And now 35427 modulus 2 is not equal to 0. That is, if 35427 is divided by 0 and the remainder is not 0. I mean, if 35427 is divided by 2 and if the remainder is not 0, definitely it's an odd number. Okay. So we'll return the whole number, that is from 0, that is from the index 0 from the start to the I plus 1, that is to the end of the string. So we'll return the whole string. That's the logic. Now coming back here, 6, right? 6 here. Now I value is less than the whole number. I value is less than the whole string, so it's before, it's less than 1. Now from 0 to the n minus 1, that is n number of substring 0 I plus 1. If we take I value, uh, basically I starts by length minus 1 and it's not starting at length, it's starting at length minus 1. That is why we are adding plus 1 here. If it is at, if it is a num string, it is not needed to add it. Okay, so this is the logic to this question. Now coming to the third question, longest common prefix. So this question is very interesting, and this can be solved by many approaches. We can use DP here also, or dynamic programming, but now here we'll just use basic string methods. Also, I would like to tell you guys that this question is asked in Google, if I'm not wrong. If I'm not wrong, I saw this as a PVQ in Google when I was solving this in LeetCode. Now, yeah, coming to this question, longest common prefix. So, I would like to tell you guys this longest common prefix is very common in strings or in arrays, or when you guys go dive deeper into trees or dynamic programming as well. So you will find this word as common. For everything the logic is same. Okay. Now what does this problem say is, we have an input array. So basically flower, flow, flight, this is the input array we are given, and the longest common prefix is just the first part. So here F is here, F is here, F is here. So F, okay. L, yeah. So L, okay. O, I. We don't have O here, so we'll stop it. We'll stop it. So the output will be FL. So this is the longest common prefix here. Okay. I hope you guys understood that. Now, what will be the logic for this question is, as I told, we can solve this by dynamic array if we are considering time complexity. Um, we'll just go through the basic method here in this video. While we are discussing dynamic programming topic, we'll discuss this question again for sure. Okay, now coming back here, what will be the logic is, the logic is very interesting here. This has many approaches. Now here I'll be using a very interesting approach. First, we'll sort this array. If we sort this array, what we get is, what we get is flower, flow, flight, right? FL is same. Now OOI, so which is least flight. So the first word will be flight, correct? Now FLOW or FLOWER. Definitely it's FLOW. Cool. FLOW. Now the other word is FLOWER. So if we sort this array, we get this. We get this array. Now, if you guys observe this carefully, the starting array index and the ending index of the array, if we compare these values, that is sufficient. we don't want to compare the middle values of the array. I will tell you why. I will tell you why. So if you guys here FL FL is same, I O O, definitely if the the part which is after the prefix is not same, that is it is not same or it is different when compared to the ending part, will uh, it is obviously sorted that it is definitely different, it is definitely different. So there is no there's no use we are comparing this one. So here we can save the time complexity. If we want to compare this one also, will be using another for loop. So that's just waste of use, that will get an extra off and complexity. So the main logic here is this one and this one. If we compare these two, that is enough. Because if if it is this is O, if this is O, so definitely this must be a prefix, right? If this is O and if this is I, definitely there these parts are different. These parts are different, and there is no use we're comparing this with this. We'll directly compare this. We'll compare directly compare this first string to the last string, right? That's all. That's the logic. So yeah, coming back here, we'll give the first string as the first index of the array, and the last is the last index of the array. Now we'll be iterating through the array. I is equal to 0, I is less than math of n, first dot length and last dot length. This is done because if we have flower in flight, if we have here flowe, and if we have yeah, coming back here, if we have fligh, and if we have flower, definitely we must be traversing through this length, because this is an extra, R is an extra piece here, and we won't be having an other alphabet to compare with this to this. So we'll definitely go through the minimum of first and last thing, right? Yeah. So that is this part. And now comparing the first and last part, if they are not same, we'll be returning the string. If they are same, if they are same. So now if so now coming here, F they are same, will append. Okay, F L L L, right? L L will append. I O, they are not same. First dot character at I is not equal to last dot character at I. They are not equal. So directly we can return the string, right? That's all. That's the logic here. We don't need to check the GHT or WER parts. Whenever the string is not equal, we can directly break the loop there, and we'll be returning the string from there. That's all. That's it. This question is that's all. And now we can solve this by regression or dynamic programming also will be that will be a very easy approach, to be honest. Okay, we'll be discussing it in the other video. Okay, now isomorphic. Now isomorphic string. So what are isomorphic strings is, carefully if you guys observe here, we have an input string and we have an input string E A G G D D. So if you guys see here, if we just change this alphabet to an other alphabet, that is if suppose if we map E to A and G to D, definitely this string is this string is equal to this string, right? uh, for example, we can map E to any letter and we can map G to any letter, but GG, uh, GG. Here it must be the same letter that is mapped to the before G. For example, if it is EG, G, and E is mapped to A and G is mapped to D, and if we have something like ADH, if we have something like ADH, this is not an isomorphic string because E is mapped to A, that sounds cool, okay. G is mapped to D, and the other G is mapped to H. That is not possible because as a character can be mapped to a single character and not two or three more characters. That is an isomorphic string. It is just replaced by another string. It is just replaced by another character. So yeah, so this is true and this is false. Okay, okay. Now coming to the logic here, what we'll be doing here is we'll basically take a vector and we'll initialize it with 200 values, that is basically 200 ASCII values, and we'll be giving 0 to all of them. We'll be giving 0 to all of them. Okay, so this S is for this index, S is for the input string S, and index T vector is for input string T. Okay, now we'll calculate the length of index, we'll calculate the length of two strings. If the length of the strings are different, they're definitely not isomorphic. Correct, they're definitely not isomorphic because each letter is mapped to an each letter, that is a different letter. Okay, so how many letters are here? Definitely those letters should be here as well. Correct. And if the lengths are different, so definitely there is an extra letter here, or definitely there is a lesser letter here. So they are not isomorphic string. So yeah, if we compare the length S dot length when it is compared to D dot length, and if they are not equal, we can return false. Okay. Now if they are same, we'll iterate to the strings. We'll iterate to the first string. Okay. Now if index S of I is not equal to index T of D of I, what does this line say is? Just a minute guys. Yeah, what does this line say is? Oh my god. Okay, I'll write it here. Oh, so what does this line say is, we had the value for E and we have the value for A in string T. That is they are mapped to different values. They are mapped to different values. For example, index S of I says that uh, in a vector index S and S of I, that is S of 0, that is E, that is E. If E is not mapped to A, then return false. Then return false. If they are mapped to the same characters, we'll just increment those values. Okay. And uh, if after this loop it still that did not return false, that is those strings are isomorphic, that is those characters are not mapped to different characters in the other string, we'll be returning true. That is all. That's the logic here. Okay, next question, right? Yeah, so next question we'll be discussing whether those two input strings are anagrams or not. What is an anagram is, anagrams are strings which have the same characters. Here in isomorphic string we map a character to the other character, but here um, here the string characters must be same. For example, car and arc. See, these are anagrams because this is made by CAR and this is also made by CAR, but the order is different. You guys understood, right? Here we have RAT and here we have CAR. Here we have T, but here we did not have T. So this is not an anagram. Okay. For this also we have so many approaches. Basically, what we can do is we can sort this string and we can sort this string and we can compare this string to this string and we can sort it. If okay, by that method, for sorting we take log n complexity, correct? So to compare those two strings, we will take n log n, but we have a data structure called hash map. By using the hash map, we can just complete it in just n time, O of n. So we'll be discussing hash map data structure here. So how to do with the n log n time is we'll just sort this string, and if we compare those strings, like putting it into a for loop by taking this string into the first for loop, and if we compare the every index of this index to the second index, and if they are not same, we'll return false. If they are same, definitely it is true. But the issue with that is that takes n log n time. Now we'll be using an unordered map here. We can use also hash table here. Here we'll be using an order map in this video. So basically what we'll be doing here is we'll take an unordered map with first as an character input and the second as an integer input. So in this character input we will have the characters of the string, and in the int we'll be storing the count. Okay. So what is the logic for this one is for every character in the string is we'll just increment the value of I mean uh, uh, will will increment the value of the particular character by 1, and and while coming to this character, that is the second character, will decrement the value by 1. So what we do here is I will just explain it here. Car and rat. Okay. So first we go through C, right? First we go through C. Here for car auto x of s, that is it just iterates the letter into in the string, will increment the value of that letter by 1. So C value increases to 1. Next A, right? A value is 1. Okay. R value is 1. Okay, sounds good. Now coming to the second loop, auto of x of t. Okay. R, right? So R, here we already have R value as 1. Now we'll just decrease the value by 1. So R goes to 0 again. A, so A value goes to 0 again. But T t. What is the case of t here? We don't have t here, and we initially had zeros. So if so, we'll um, here we initialize the map with zeros, right? So we don't have t values here. We don't have t values here, but we have an extra t value here. So we'll take it with -1. We'll take with -1. Now coming to the other loop, for auto x of count, if x dot second is not equal to 0, return false. What does this mean is, if it is not 0, definitely that character is an extra character. That character is an extra character. See, because here we have r value as 0, and you guys can see that r is in this string and this string as well. We have a value as 0 because we have a here and a here as well, but we don't have t value. We don't have t in this string, but we have t in this string. So t value is -1. So definitely that is an extra value. So t value is not equal to 0. Correct. So if x dot second is not equal to 0, here second means is the unordered map's second part. That is, the first part stores the character and the second part stores the count. So if that part is not 0, we must return false, because this string and this string are not equal, because t is an extra value in this string and we don't have t here. So definitely those are not anagrams. If this whole condition fails, so definitely they must be anagram. So we'll return true at finally. And this is the end of this question. So I hope you guys uh, learn something through this video. I definitely recommend you guys to practice these questions in LeetCode as well. Until then, goodbye. This is Karthik signing off.